Although no evidence of life has been found on Mars, new research from NASA suggests that microbes could find a potential habitat beneath the frozen water on the Martian surface. The study shows that suitable conditions may exist for microorganisms capable of photosynthesis under the icy surface of Mars. NASA researchers have demonstrated through computer modeling that water ice on Mars can transmit enough sunlight to reach shallow pools of water beneath the surface. These conditions can create environments in which life forms such as algae, fungi, and cyanobacteria, microorganisms that perform photosynthesis on Earth, can survive. A diffeer color of the Jet Propulsion Laboratory describes the glaciers as one of the most accessible places in the search for life on Mars. There are two types of ice on Mars, water ice and carbon dioxide ice. By examining water ice in Martian glaciers that formed millions of years ago, Culler and his team showed how these glaciers can melt when exposed to the sun, forming pools of water. Dust particles accumulating in the ice can trigger melting several meters below the surface, potentially creating an environment suitable for photosynthetic microorganisms to survive. On Earth, gaps in the ice, known as cryoconite holes, are formed when dust particles absorb sunlight. This process could also occur on Mars, and these tiny cavities could create pockets of water beneath the surface, providing a habitable environment for microorganisms. Phil Christensen from Arizona State University states that on Mars, this process may cause the ice to melt from the inside out. Due to the atmospheric conditions on Mars, water ice on the surface is expected to directly evaporate into gas. However, these conditions below the surface are different and liquid water can form, especially under the influence of dust particles. Previous work by Christensen and Culler had shown that dusty ice on Mars could melt to form liquid water. This new research suggests that ice can transmit enough light 3 meters below the surface for photosynthesis to occur. The study shows that shallow meltwater pools are likely to form in the tropical regions of Mars between latitudes 30 and 60 degrees. These regions could potentially be critical points to target for future human and robotic missions. Culler aims to test these theories by recreating the dusty ice of Mars in a laboratory environment. These potential habitats in Mars ice caps could be an exciting step in the search for possible life on the red planet. The fact that sunlight can reach these subsurface pools and photosynthesis occurs offers a hopeful sign for life on Mars. Frozen water on Mars is not only a matter of scientific curiosity, but also of great importance for future manned Mars missions. These ices can be used for the production of oxygen and rocket fuel, as well as the water needed for astronauts to survive. Additionally, frozen water on Mars could also be an important source for future terraformation of the planet. The discovery of frozen water on Mars supports the idea that water was more common in the planet's past, perhaps creating conditions suitable for the emergence of life. By studying glaciers on Mars, scientists are trying to better understand the planet's climate history and predict future climate changes. The discovery of frozen water on Mars is an important step towards unlocking the mysteries of the red planet. With exploration missions in the coming years, we will be able to learn more about the water on Mars and better evaluate the habitability potential of the planet.